Hey guys, it's Obi here. So up to this point, we've learned how to calculate our gear ratios, simple ratios and complex ratios, which would be a gear train. So to this point, as of right now, we've really just done the ratios in the transmission. Okay, so we have to understand that that is not all of the gears that we're going to have in a vehicle. So I want to make sure everybody understands. Right now, we have calculated the transmission. We have to understand, though, if my button will stay, that we also have one more set of gears, and that is back here at the differential. Okay, so we have a ring and pinion unit that looks just like this. And the ring and pinion unit is used to transmit power 90 degrees, and we also use it as our final reduction for the vehicle. So we have a pinion gear right here, and this is turned by the drive shaft. And as this pinion turns, it is forcing a ring gear to rotate, which is in turn forcing the axle shafts to rotate to go out to the vehicle. So this is what's finally causing our tires to turn, okay? So to calculate our total ratios, we're going to do step 1 today, and then tomorrow we're going to talk about the actual speed of the vehicle with the tire size and the radius or the circumference of the tires. So today we're just going to make sure we understand how to do these ratios. So this is how your assignment's going to be set up. Everyone is going to look just like this. So what we need to do is calculate our total ratio for the vehicle. You'll have 4 questions that are going to be just like this, and basically we know we have 2 gear sets in the transmission to make up 1 gear. So we have our gear set number 1, which is this component right here. So we see our gear set number 1 is 30 over 24. Okay. So we have 30 over 24. So if we calculate that out, we will find out that we have a 0.8 to 1 ratio. That's actually an overdrive ratio. The next gear set we have, and we can see it's for first gear. So for first gear, we can look and we have a drive gear of 10 and a driven of 37. So one thing we got to realize is that when we are talking about ratios on a transmission, it seems like somebody kind of got confused with this. So this is the drive and this is the driven on the first gear set, and then for the second half of the transmission ratio, this is now the drive gear and this is the driven. Okay, we kind of have to remember that and make sure we're on the same page, because that can get a little confusing what gear is what. Now, for today's example, we are just going to calculate what's there. So I've already put those on for you to help. But so we know we have 30 and 24, and then our gear set number 2 in the transmission is 37 and 10. Okay, and that is going to give us a ratio of 3.7 to 1. Now, the final step we have to do is calculate the ratio of our differential. So a differential, in this particular one, we have 37 teeth on the driven, which would be the ring gear, and our pinion, which is always the drive, is going to be 9 teeth. So if we do the math on that, which I'm sure you guys know how to do this, you've done it about 100 million times by now, is 4.11 to 1, okay? So this part here is not different from anything you've already done. The only difference is we have one more calculation, okay? So instead of just multiplying the first, or the ratio of the first gear set and the second, we're going to do that multiplication, and then we're also going to multiply that by the third one, okay? So if we multiply all 3 of those together, and you can multiply it as 0.8 times times 3.7 times 4.11, and the product of that is going to be 12.1656, which we would round that up because it's 5 or greater to 12.17. So your total ratio is going to be 12.17 times the input shaft is going to turn for 1 revolution of the axle. Okay? We'll just do one more example really quick. So our drive and our driven, and in this situation it's actually the same. So we'll see that we're still at 0.8 to 1. And then our gear set number 2, the ratio for that was 18 on the drive and 20 on the driven, which is going to give us a ratio of 1.11 to 1. And then our differential in this example is 14 to 38. So 14 on the pinion gear and 38 on the ring gear. And that will give us 2.714. So if we add all of those together, our total is 2.4 to 1, okay? I hope this helps you guys. If you have any questions, feel free to call me, and I will be happy to help you. But I think you guys got it covered, okay? So I will talk to you guys tomorrow when we start talking about tires, okay? See you later. Obi out.